Assalamualaikum warahmatullahi wabarakatuh, and hi everyone, I'm Ainnur from group 5. So, this is my teammates Azira and Jannah. Our group has chosen maximum and minimum problems, which is under the application of differentiation for this assignment topic. Let's start! Did you know what is differentiation? In calculus, differentiation is one of the two important concepts apart from integration. Differentiation is a method of finding the derivative of a function. It can be applied to measure the function per unit change in the independent variable. How about apply maximum and minimum? Actually, the process of finding maximum or minimum values is called optimization. Are we using it in our daily life? Yes, of course. We are trying to do things like maximize the profit in a company or minimize the cost and even find the least amount of material to make a particular object. Well, these are very important in the world of industry. By using differentiation method, we can solve our problems. What are we waiting for? Let's take a look.
Our group has took this question as an example of our problem statement. A right-closed cylinder with radius x cm and height y cm is placed on a square block with sides 2x cm and height x cm. So from this statement, we know that this cylinder has a radius of x cm and y cm height. Meanwhile, this square block has 2x cm sides and x cm height. Let's solve question A. If the total volume of the cylinder and square block is 27 cm cubic, express y in terms of x. We can get the total volume by adding the volume of square block with the volume of cylinder. Since it has been given before that the total volume is 27 cm cubic, so 27 is equal to the volume of square, which is 2x times 2x times x plus with the volume of cylinder, which is pi times x squared times y. We will get 27 on the left hand side and 4x cubic plus with pi x squared y on the right hand side. Then we move 4x cubic to the left hand side and it will turn to 27 minus with 4x cubic here. The question asks to express y in terms of x, so we need to move pi x squared to the left hand side. Therefore, we will get 27 minus 4x cubic divide with pi x squared equal to y. As the final answer, we must rewrite it and tada! Y is equal to 27 minus 4x cubic divided with pi x squared.
I am Jannah and I will present a back-purpose solution for question B. Show that the total surface of area of the square block and the cylinder is A equal to 54 over x plus 8x squared. Find the values of x and y that minimize the total surface of area. So firstly, we have to state the formula of area of square and the formula of area of cylinder. Next, we got 2 times length times h plus 2 pi rh, where r is radius and h is referring to height. So we just substitute the value of length and height according to the question. So 2 times 2 4x squared plus 2x squared plus 2x squared plus 2 pi xy. Next, 16x squared plus 2 pi x. And we substitute the value of y in terms of x according to the previous slide that have been explained by Ainnur, where we got 27 minus 4x cubed over pi x squared. And finally, we got the answer 54 over x plus 8x squared. If you look on the right hand side, 16x squared plus 54 minus 8x cubed over x, and then you do the mathematics calculation, and then you got the final answer also 54 over x plus 8x squared, which the answer of the area of the square block and the cylinder has been proven. Find the value of x. So firstly, we have to find the first derivative of area of square and the cylinder. So the x must move the upside, and then we got 54x, the power of -1 plus 8x squared. So the a over the x equal to -1, where the power of x, -1, move to in front of the 54 to times them, and -1 minus 1, we got negative 2, plus 2 to the power of x, move to in front 2 times with 8 and x. So we got negative 54 over x squared plus 16x. When dA over dx equal to 0, draw down what you got on the left hand side for the dA over dx, and you do the mathematical calculation, and you got x equal to 3 over 2 centimeter or 1.5 centimeter. Now we want to find the value of y, so we just use the value of y in terms of x, where Ainnur has explained on the previous slide. 27 minus 4x cubed over pi x squared, and then we substitute the value of x on the left hand side that we just got before this. So 27 minus 4 times to 3 over 2 to the power of 3 over pi times to 3 over 2 to the power of 2. And then we got the final answer. The value of y is 6 over pi centimeter or 1.91 centimeter. And then we want to find the second derivative of the area to find the minimum value of area. So we have to find second derivative. So negative 2, where the power of x moves to the front 2 times to the 54. X negative 3, where negative 2 minus 1, we got negative 3, plus 16 times to 1, where x the power is 1 minus 1, we got 0. X power of 0 is 1. So the final answer for the second derivative is 108 over x cubed plus 16. And the next step will be explained by Azira.
Thank you, Jannah. I am Azira, and I will explain the next step of this problem solution for question B. In this step, we need to find the second derivative by substitute x value that has been found into the second derivative equation to determine whether it is greater or less than 0. Thus, 3 over 2 is being substituted into the second derivative equation, and the value we get is 48, which is greater than 0. So our x value is minimum value. On the other hand, if the second derivative is less than 0, it is maximum value. Next, question C asks to determine the minimum total surface area. This problem can be solved by substitute x value, which is 3 over 2, into the surface area equation. Hence, the minimum total surface area for this question is 54 cm². Conclusion. Firstly, application of differentiation is an important concept for solving maximum and minimum problems. Second, the steps used to solve the given question is to find the derivative. Then, let the derivative equal to 0 and find the values of the variables. Next, find the second derivative, and if the second derivative greater than 0, it is minimum value. Meanwhile, if the second derivative is less than 0, it is maximum value. Lastly, minimum total surface area has been found by substitute x value into surface area equation. All of these are the references that has been used in our presentation. That is the end of our presentation. Thank you for watching.